So today in Math 3, we're going to look at transformations of exponential and logarithmic functions. Now again, this is a good thing because we've looked at transformations now a number of times. Okay, we even did transformations in the last unit. So we're just going to look at transformations for this. All the same rules basically apply to these functions just like they did before. So here's our exponential function. Okay, so what we have here is we're going to base this off of 5x. Think of that. But if we look back up here, we can see all where the transformations are happening. So here's your a value. So if you're multiplying something before the base, so if you think about the base for our equation, our base is going to be 5, just like it is here. Okay. So if you're multiplying something in front of the 5, that's going to be your vertical stretch or compression. If you're multiplying something in front of the x term, okay, so if you had, let's say, 5 times 2 to the x, that 2 would be your b value, and that would be a horizontal stretch or compression. Right? If you're adding or subtracting something on the x as an exponent, then that would be your c function, c value. That would be your horizontal shifts. If you're adding or subtracting something in the outside of the function, that's going to be your vertical shifts. Okay, so all these things work the same as before, and let's check them out. Okay. So for your vertical stretch, if your a value is between, if your a value is greater than 1, you're going to have a vertical stretch. Okay, so if you had, an example would be f of x equals 2 times 5 to the x. This 2 would be your vertical stretch. Okay, your vertical compression, your a value is going to be between, it's going to be greater than 0, it's going to be less than 1. Okay, so an example of that would be if you had f of x equals 1/2 times 5 to the x. This 1/2 would make it a vertical compression. Now your reflection over the x-axis is if you have a negative value in front for the a. So if you had f of x equals negative 5 to the x power. Okay, this negative sign here is going to be your reflection over the x-axis. All right. Next, your b value. So your b value is going to be if something is multiplied times the x as an exponent. So for horizontal stretch is basically the reverse of your verticals. Okay, so your horizontal stretch is if a is going to be between 0 and 1. So if we had f of x equals 5 to the 1/2 x power, okay, that would be a horizontal stretch. And your horizontal compression is going to be like your vertical stretch. Your a value is going to be bigger than 1. So that would be like f of x is equal to 5 to the 2 times x power. Okay. And the reflection over the y-axis is if the x term is being multiplied by -1. So if you have f of x is equal to 5 times negative x. All right, that negative sign is going to be your reflection over the y-axis. Okay. All right, moving on to the shifts, horizontal shift. If you have a horizontal shift to the left, that means it's going to be a positive in the next to the x value, adding a number. So if you had f of x equals 5 to the x plus 2, let's say. That plus 2 means you're going to move the graph to the left 2 spots. Okay, remember it's opposite of the sign you would think it would be. Horizontal shift to the right would be if you have a minus sign. If you're subtracting x to the x. 5 to the x minus 2. Okay. So the other thing about this is it changes your asymptote. So if you're finding the inverse of a exponential function like we were dealing with, it's going to change, and you're moving the graph horizontally, that's going to change the vertical asymptote of your inverse. Okay. And we'll get into more of that when we look at the graphs themselves. Okay. And here, vertical shift is if you add or subtract something on the outside. So if you have f of x equals 5 to the x, but then it's plus 2, not next to the, I'll put this in parentheses to make it easier. It's not next to the x itself, it's on the outside of the x. Okay, that's a vertical shift up, vertical shift down. Same idea, but now it's just going to be minus 2. Excuse me. Okay. Now this vertical shift is going to change your horizontal asymptote of this function. Okay, remember this function, if it's increasing or decreasing, there's a horizontal asymptote at y equals 0, which is on the x-axis. If you're graphing, if you're shifting your graph either up or down, it's going to change your horizontal asymptote. Okay, so let's now look at some of these and see how they look as transformations in your equation. Okay. So we're going to see a couple different examples of different types of function notation. Okay, this one, the first three are done with the actual equation. Okay, so we have two different things happening in this. We have the plus 4 right here. This is a horizontal shift. This is going to the left by 4. And then the negative 1 is a vertical shift. And it's going down by 1. Okay. The 7 is the base, so that doesn't change anything. That is not the vertical compression or stretch. That is the base. The 7 is the base. So you see that when we do a part B. So 3 is now going to be a vertical stretch. Okay, because it's being multiplied in front of the 7, which is the base. There's also that minus sign in front of the 3. That is your reflection over the x-axis. And then the plus 1 next to the x is a horizontal shift. And that is going to the left by 1. So there are 3 different transformations on part B. Okay. Next we have part C. We have 3 things going on here as well. We have the 1/4 out in front, which is a vertical compression. Of 1/4. Okay. The negative sign on the x term itself is going to be reflection, but this time it's over the y-axis. And then lastly, the plus 4, because it's not on the x itself, it's not adding as part of the exponent, it is a vertical shift. Oh, that's ugly. It's going up by 4. Okay. Now the other notation we have here is it's like the function notation. We've seen this in the past. So what is happening? So the 2 is inside the function. It's being multiplied. So that is a horizontal compression. By 2. And then 3 is on the outside being added, so it is a vertical stretch. Or no, sorry, a vertical shift. And it's going up by 3. Okay, so there's only 2 things happening in part D. In part E, there are 4 things happening. Okay, first thing you have is the 4 is a vertical stretch. We have the negative sign in front of the 4, which is a reflection over the x-axis. We have the plus 1 on the inside of the function. That is a horizontal shift. And since it's plus, it's going to the left by 1. And last, we have a minus 5, which is a vertical shift. That is down by 5. All right, last one of these types. There's two things happening here. There's the 1/3 out in front. That is a vertical compression. By 1/3. And then we have the negative sign on the inside being multiplied by the x. That is going to be a reflection, this time over the y-axis. Okay, so there's a bunch of different examples for those. Let's look at the next type, and this is going to be the same ideas as the ones that we just did, but we're looking at logarithms, okay? So it's the same thing, basically, that we did before. So I'm not going to actually go through all these. I'm going to highlight a couple different things, but I'm not going to go through these because it's the same transformations as we've just dealt with. So if you're multiplying on the outside, it's a vertical stretch or compression. Multiplying next to the x, it's a horizontal stretch or compression. Add or subtract inside by the x, it is a horizontal shift. Add or subtract on the outside, it is a vertical shift. And then the reflections over the x and y axis are the same. If it's out in front, it's over the x-axis. If it's on the x itself, it's over the y. The only two things I want to highlight in this, because they are the same, is that if you have a horizontal shift here for these logarithms, it changes the vertical asymptote of the, not the logarithmic function, but the exponential function, okay? And then this changes the horizontal asymptote if you have a vertical shift. So it's the same thing we just saw for the other ones. It's kind of, they're mirror images of each other because they are inverses. So let's look at some examples to show you just what this looks like in terms of the changes. Okay, and again, we're going to show you two different versions, the logarithmic equations written out, and then them as function notations. Okay, all right, so we have two things going on in part A. We have a horizontal shift. All right, and that's going to the right by 1 because it's negative. And then the +2 is a vertical shift. Oops, I spelled that wrong. Going up by 2. All right, in part B, we have three things. The first one I'm going to write down is the vertical stretch. By 3. And because the 3 has a negative sign in front of it, it is a reflection over the x-axis. And lastly, we have a vertical stretch. Not a stretch, vertical shift. I get it. Up by 4. Okay. And then part C, we have two things. We have a horizontal compression. By 2. I did a little bit long. And we have a vertical shift going down by 7. That's it. All right, now let's look at the other notation of our equations. We have two things happening. We have a multiplication on the outside of the function, which is a vertical compression. By 1/5. All right, and then we have something being added on the inside of the function. This +2 is going to be a horizontal shift. It's going to go to the left by 2. Next, this negative sign being multiplied times the x is a reflection. But since it's on the inside, it's over the y-axis. And then the +6 is a vertical shift. Oh, I'm going up by 6. Sorry, something on my screen. All right, last one. Oh, got a lot of stuff here. There's 4 different transformations. Okay, we have a vertical stretch by 3. Whoops. Got a letter. All right, the negative sign in front of the 3 is a reflection. Oh my goodness. Over the x-axis. The +2 is a horizontal shift. Going to the left by 2. And lastly, the -1 is a vertical shift. It's going down by 1. Okay, so that's it. So the transformations, we've been looking at transformations for a while. You should have a good idea of how to do these. Just because the equation changes doesn't mean the rules change. The rules have been the same each and every single time. All right, it's just that the equation looks different. Okay. All right, so please try the practice and get help if you need it. Ask questions,